This video describes one of the key elements of the published project, the gripper, designed to work with a FANUC robot. The gripper performs gripping, positioning, fixing, and transferring of the product components. Due to the absence of suitable models in the RoboDK library and online, it was decided to design a custom gripper. Its construction is adapted to the specific project tasks, taking into account the need for high positioning accuracy when handling the base part of the product, its gripping and precise placement, as well as the stiffness ribs. On the GrabCAD platform, 2 gripper models were selected as a base, one for editorial adaptation into the main gripping mechanism, the other for adaptation into additional fixing mechanisms. I worked with STL models in FreeCAD and Fusion 360, performing component arrangement and basic preparation, and in RoboDK for final assembly and mechanism creation. The assembled gripper system consists of 1. A main 2-finger gripper with linear opposing movement. 2. 10 auxiliary fixators mounted on the fingers of the main gripper, implemented in 2 configurations. 2 synchronized fingers with linear opposing motion. 3-component single-axis mechanism. 1 movable finger, 2-component single-axis mechanism. All components were integrated directly in the RoboDK environment. The implemented gripper design allows gripping components of different types and sizes, independently controlling each mechanism, applying a step-by-step gripping approach, compromise solution for the main gripper. During implementation, it was revealed that in RoboDK, creating a 3-component single-axis mechanism with linear synchronized opposing motion of active fingers does not support assigning a separate reference frame for each of them. Since my goal was to build a 2-finger mechanism with the possibility of placing additional gripping modules on each finger, the decision was made. Based on 3 elements, 2 2-component single-axis mechanisms were created with opposite attachment of fingers to the base of the gripper. This approach allowed assigning a dedicated reference frame to each finger. Each mechanism controls a single finger, and both are installed on a shared reference frame in opposing directions. Advantages of this solution: independent control of each finger, ability to attach separate groups of fixators on each finger, full integration into the RoboDK structure without functional limitations. Although a compromise, the solution is fully functional within the capabilities of the simulator and the project requirements. The gripper design includes 8 internal fixators for securing the base product component, 2 side grippers for handling the stiffening ribs. For operation with the FANUC robot, 2 TCPs were assigned, TCP-1 central module, TCP-2 side grippers. After completing the 3D modeling stage, the gripper was fully structured in RoboDK, 15 reference frames, 12 mechanisms, 28 elements in total, 27 targets for motion programming, and 3 additional 3D objects added at the final stage. Program structure for gripper use: 30 offline programs for TCP-1 and 9 offline programs for TCP-2. Additional technical features: asynchronous movement of the main gripper fingers. First finger, with 4 vertical single-finger fixators, performs linear motion of 39 millimeters. Second finger, with 4 horizontal 2-finger fixators, moves in 2 stages. First stage, a 39 millimeter stroke synchronized with the first finger. Second stage, an additional 10 millimeter stroke in the direction of TCP. This enables precise positioning of the object for double-sided gripping. This solution is not optimal in terms of positioning accuracy and does not fully correspond to the type graphically represented by the gripper design. In real equipment, grippers of this type operate exclusively based on synchronized finger movement. In RoboDK, it is not possible to reliably implement a complex synchronized approach in which the fingers of the main gripper close simultaneously at 44 millimeters, while the robot TCP1 is shifted by 5 millimeters in parallel. The issue arises due to simulation instability at different speed modes. For this reason, a simplified solution was chosen. Although the original gripper design plan involved implementing a complex synchronization of finger and robot movements, the compromise approach proved more stable within the simulator environment. Side grippers, 3 positions, 1, closed, gap of 2 millimeters, 2, fully open, 3, intermediate locking, first gripper, 20 millimeters, and second gripper, -8 millimeters. The intermediate locking positions are used for gripping the ribs from a horizontal position, followed by transfer to the gravitational calibrator. Conclusion: the gripper design is fully implemented in RoboDK, built on reference frames and mechanisms, programmed offline, optimized for simulating complex multi-level interactions.